Mrs. Wagner here. So this video is for Unit 2, Lesson 1, Describing Matter. And I'm going to go through the process of our quantitative measurements for our object. So each group has been given an object, and you have to come up with 10 qualitative observations. So those would be observations that you use to describe the appearance. Is it shiny? Is it dull? Is it bendable? Is it flammable? Is it magnetic? So ways that we can use words to describe our object. This video is going to go through how to figure out quantitative observations. So these would be any observations that use numbers. Quantity means number or value. So I'm going to go through how to mass the object, how to figure out its volume using water displacement, and then using those two measurements, how to figure out its density. Okay? All right, so let's first do mass. Okay, so I have our little scale here, so I'm going to take off the plastic cover and make sure that it is at 0. All right, there it is at 0. Taking our little washer, placing it on the scale, and it is 3.2 grams. So I'm just going to write that down on the board behind me. Okay, so 3.2 grams. Now we're going to figure out the volume. Okay, so we know mass is how much stuff the object has in it. So how much matter is in this, how many particles basically would be in this little washer. That's its mass, okay? And volume is how much space it takes up, okay? So this is not a block. This is not something that we can easily measure length, width, and height. So if this were a block, we could measure its length, we could measure its width, and then its height, multiply those three numbers, and we would get our volume in cubic centimeters. But because this has all weird different kinds of edges, there's a hole on the inside, we really can't easily measure it with a ruler. So instead, another way to figure out volume is water displacement. So we know that this takes up a certain amount of space. If I place it in water, it's going to take up the space inside the water. It's going to cause the water to rise. Okay? And whatever the amount the water rises is the amount that this is in milliliters, because that's the amount of space it takes up. Okay, so with our little graduated cylinder, this is a small graduated cylinder, appropriate for something that's not going to take up a lot of space. A larger object might need a larger graduated cylinder. Now, the problem with having two different sized graduated cylinders is your numbered increments end up being different amounts, okay? So with this particular graduated cylinder, we can see that every increment, every line is 1 milliliter. So to get to the 10 to the 20, each line in between is 1. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, all the way up to 20. Okay, so when the object, let's say, goes from 10 to maybe the second line, that would be 2 milliliters. So it would go 10 up to 11 up to 12. And that means that the little washer took up 2 milliliters of space. So you take the old amount of water, when you add the object, it rises, the water rises, and then the new amount is going to be higher than the old amount, so you subtract. So 12 minus 10 is 2. So that's 2 milliliters for this particular washer. Now that's just an example. I'm actually going to test and see what is the volume of this washer. However, I've got to use a smaller graduated cylinder because I don't think this washer is going to take up a full 2 milliliters of space, okay? So now with this one, because the numbers are smaller, this one's a little bit more difficult to see because it is smaller. Every line in between is 0.2. So you can see my water level is at 4, and there is the 5. So every little line in between is 0.2. So 0.2, 0.4, 0.6, 0.8, and then 0.10. Okay, I'm going to try to bring it a little closer. Unfortunately, it's not going to be very clear, but you can sort of see it. And you have these in your classrooms, and your teachers can show you for your particular graduated cylinder what your increments are. So this one is 0.2 for every line. Okay, so I've started at 4. Now the way to read this is you want to get down and you want to see where the water is at eye level here. Okay, and we can see that it is at 4. You want to get the very bottom part of the water, so it's going to dip a little bit. You're going to see a little bit of bend in the water. So the very bottom part of the water is what you read, and I'm reading this at 4. Now I'm going to add my graduated cylinder, but one way I want to do it is I want to tilt this and then easily slide it in so it doesn't splash. And there it goes. You can see it in there. You can see that the water went up now. 2 lines. Now I remember that every line on this particular graduated cylinder is 0.2. So it has gone up 2 lines. Actually, it's gone up, this has gone up 3 lines. I don't know if you can see that. That's 3 lines. Okay? So that's 0.2, 0.4, 0.6. 0.6. Okay, so I'm going to make sure I get that decimal in there. So 0.6 milliliters is the volume, because that's how much space it takes up. That causes the water to rise, 0.6. So that means that the washer is taking up 0.6 milliliters of space. So on my whiteboard here, I'm going to write 0.6. Okay? Here we go. Okay, now, that's 2 quantitative measurements. For my third quantitative observation, I'm going to do density. So to figure out the density of an object, all you need to do is divide mass divided by volume. So you're going to take the mass and divide it by its volume. Okay, that's a 6, so it's 0.6. So the density, if I take mass divided by volume, I plug in my numbers, 3.1, whoops, 3.2 actually, isn't it? If I take 3.2 and I divide it by 0.6, which is its volume, I'm going to get a density of 5.2 grams per milliliters. So that's how many grams, so it's 5.2 grams per milliliter is the density of the object, okay? And it sinks, so the fact that it sinks means it's got a density more than 1, because water's density is 1. So anything more than 1 is going to cause an object to sink in water. And we did see that our little washer sunk there in the water, okay? So for my third quantitative observation, I can say it has a density of 5.2 grams per milliliter.